In this video, we'll take a look at the simple maximization problem in section 7.1. This is a linear programming problem that seeks to maximize profit, a profit maximization problem. In the text, we're told of a company, RMC Incorporated, a small manufacturer, that manufactures a couple of products. It manufactures a fuel additive and a solvent base. We're told that there are 3 raw materials required for the production of these 2 items, and we're provided with some details about how much of each raw material goes into each of the products. So of the 3 raw materials, they are blended such that 4/10 of a ton of material 1 and 6/10 of a ton of material 3 go into the fuel additive, and 5/10 of a ton of material 1, 2/10 of a ton of material 2, and 3/10 of a ton of material 3 go into the production of a ton of the solvent base. We're told that during this production cycle, RMC Inc. has available 20 tons of material 1, 5 tons of material 2, and 21 tons of material 3. We're also provided with the profit contribution of each item. So the fuel additive provides a $40 profit contribution for every ton of fuel additive. And the solvent base provides a $30 contribution per ton. Let's go ahead then and design a linear programming solution to this problem. The first thing we want to do when setting up any linear programming solution is to answer the question, what are we making? Well, we're making, in this case, a fuel additive and a solvent base. All right. Then the next question is to decide how much should we make. What is the solution? So we'll have a solution line here. This is where we're going to have solver put the solution, and I'll color code this yellow, and I'll do that every time so that you know where the solution line is. This is how much we're going to make of each of the products. What we want to know, though, is what is the profit? What is the maximum profit that we will make from a product mix at this level? So we're going to put profit. This is a profit maximization problem. Now let's enter the profit contribution for each of our items. It's $40 for the fuel additive and $30 for the solvent base. I can center those, a little easier to read. We're going to have solver calculate the optimal solution by substituting production quantities here at these levels of profit and finding the maximum profit to be earned from any combination of production of these 2 items. And I will set this solution to green so that you can see that. Now, when we do this, since we don't have unlimited resources, we're subject to some constraints. So we'll have to enter those constraints here. I'll list them. We're provided with a raw material constraint for raw material 1, one for raw material 2, and one for raw material 3. We know that as we use these raw materials, that we're going to put 4/10 of a ton of raw material 1 into the fuel additive and 5/10 of a ton of raw material 1 into the solvent base. No, the fuel additive does not use any of material 2, so we'll just leave that blank. You can put a 0 in there, we'll leave it blank. but it uses 2/10 of a ton for the solvent base. And the production process uses 6/10 of a ton of raw material 3 for the fuel additive and 3/10 of a ton for the solvent base. I'll just center those so they're a little easier for you to read. This is subject to some constraints. We only have so much raw material 1, so much raw material 3, and so much raw material 4. So these are maximum constraints. We can't exceed these volumes. So whatever the solution is has to be less than or equal to each of these values. We'll just put that symbol there so we remember what kind of constraints these are. It becomes significant later. Then let's put in the actual constraints that we were provided. We were provided with 20 tons of raw material 1, 5 tons of raw material 2, and 21 tons of raw material 3. Now what we want Solver to do is to create a model where it substitutes various values here within these constraints and gives us then our maximum profit. So we will put these constraints right here. Let's go ahead and make that blue so that you can see. We'll have Solver put the quantity used of each of these materials in here in order to reach the optimal solution. At this point, we just about have the model set up. We need to do some sum product work. We need to give Solver something to work on. And the sum product function is used in the same way throughout the problem. We're always going to take the sum product of the solution set. The yellow row, we make that absolute. Then we take the sum product of the row to our left. Enter that. Do it again just to illustrate the sum product of the solution set. And we make that absolute, comma, and then the row to our left. It's the same all the way down. So we could just copy that, but for the sake of repetition, I'll do it again. Sum product of the solution set, and make that absolute, and then the row to our left. Copy that down, and you'll see that press F2, relative and absolute cell references allow me to copy it down. Now, because there are no values here, these all resolve to 0, but once we invoke Solver, Solver will then find the solution for us. So I'll go up to the Data tab. I always put my cursor right here on the green cell, and I'll show you why. I go to Data, I select Solver. Solver comes up, and the first thing it wants is the objective to set, and that's this value. This green value is our optimal solution set. So I would have to put my cursor here anyway. It's a profit maximization problem. We're going to maximize profit by changing the variable cells, and we want it to change these yellow cells. Substitute values there. And we're going to add some constraints. We click Add. I always move this over so I can line up my signs, make sure my signs are the same. You see I have a selection of signs here. First thing it wants is the cell references. These are the cell references. These are where the values will go. Then this represents the constraints themselves. I'll select OK since I don't have any other constraints to add. Now Solver is just about ready to go. I want to make sure that Make Unconstrained Variables Non-Negative is selected or checked. And this is a linear problem. So for linear problems, we use the simplex linear problem, or LP method. And I'll select Solve. Solver solves the problem. It also prompts me to provide it with the report. And in the text, it talks about the answer report. So we'll go ahead and click on Answer and say OK. You can see that it creates an answer report down here. And all the answer report does, we'll look at it in a moment, is it summarizes our solution. And our solution is to produce 25 tons of fuel additive, 20 tons of the base. We'll make $1,600 in profit. And we'll use all 20 tons of raw material 1, 4 of the 5 tons of raw material 2. So we have a ton of slack material. And we'll use all 21 tons of raw material 3. If we go to the answer report, Solver then breaks that down, provides the same information. The profit we'll make is $1,600. We're going to make 25 tons of the fuel additive, 20 tons of the solvent base. We're going to use all of raw material 1, no slack, so it is a binding constraint. We'll use 4 of the 5 tons of raw material 2, leaving 1 ton of slack, which is characteristic of a non-binding constraint. We'll use all 21 tons of raw material 3, leaving no slack, binding constraint. This only helps interpret this. You can see all of that here as well. The text then goes on to suggest that the profit for the solvent base is increased to $60 per ton. You can see that Solver finds a new value here, but it may not have calculated everything else correctly. So I'm going to put my cursor here in cell D5 on the optimum solution set, invoke Solver. Everything is the same, so I'll select Solve. I'll go ahead again and have it create a new answer report. Creates answer report number 2 down here. You can see that my new optimal solution is $2,250 in profit, making 18.75 tons of fuel additive and 25 tons of solvent base. In this case, we use all of raw material 1 and all of raw material 2, so there is no slack here, but we only use 18 3/4 ton of raw material 3, leaving a 2 1/4 ton slack amount. So this becomes then the non-binding constraint. That's how you solve a simple linear programming profit maximization problem using Solver in Excel.